All right. On Tuesday, you got a sheet. Up at the top of the sheet, it said something about the torture test is coming Friday, and then there were four problems that had different sets of different information about matrices in them. Here is here is the notes for that. Okay, because they're all problems that have variables in them. So when I start putting variables into matrices, what does that take out of your hand? It takes calculator out of your hand, and you got to understand how to do them. Okay? And so, along those lines, if you check on the back of today's review, the first page is a no calculator page. You'll get a no calculator page tomorrow first. Then when you finish the no calculator page, if you flip over on the back and look at it, that's your bonus. That's one bonus. There's three parts to the bonus in this chapter. That's the first part. The other parts I'll go through as we talk. Okay, so what you had, guys, that was the day we got this first. All right. On Tuesday, we went over all the stuff that you need to know for your test. Then Wednesday, you took the graduation test, and so I reminded you that in your book, for those of you that need the notes, it talks about identity matrix. Remember what makes up the identity matrix is 1 across the diagonal, 0 everywhere else. It tells us how to find the inverse. How to find the inverse of a 2 by 2 matrix. We have to be able to do that with pencil and pen. You don't have to be able to find the inverse of a 3 by 3 matrix, but you do have to be able to find the determinant of a 3 by 3 matrix. So if you need the notes on the determinant of a 3 by 3 matrix, there that is. And then we'll set up the problems with Cramer's rule here in just a second. All right, the first thing that I asked you to do on that page that you had Tuesday was to solve these problems using Cramer's rule. When you do Cramer's rule, to do it, there's three matrices you have to set up. The first matrix you have to set up is a denominator matrix, and you get that from your coefficients. So what would that be? 1, -4, -2, 5. Remember, when we call out matrices, we always call out row by column. Then I've got x sub n. I'm going to put x sub n. I started doing that yesterday just because it's the x numerator. So x sub n is the x numerator. So I take 10 and -11. I put it in the x column, and what goes in the y column? Yeah, -4 and 5. Y sub n. Again, I take 10, -11, and I put it in what's considered the y column. And what goes in the x column? 1 and -2. All right, that's Cramer's rule. That's what I asked you to do on that table right there, is you set up your three matrices. Then, when you calculate these, 5 minus, I cross multiply, I get 5 minus 8. 5 minus 8 is -3. So x's denominator is -3. Y's denominator is -3. Okay? The numerator, 50 minus 44. What's 50 minus 44? 6. So I take that 6 and I make it the numerator here. That's why I started using that subscript n, so that you would understand that x's numerator comes from that matrix. Okay? So the y matrix is -22 -11 cross multiply minus -20 negative 11 minus negative 20, positive 9. That positive 9 becomes the numerator for y. So I put a 9 right there. Again, that's why I started using the subscript y sub n. As y sub n is a pretty useful little subscript. So y sub n over d ends up being negative 9 over 3, so that's negative 3. This is negative 2. And the part that I can't seem to get across to you guys is that, guys, it will work. If you take negative 2 and subtract 4 times negative 3, negative 2 plus 12 is 10. Negative 2 times negative 2 is 4. Plus negative 3 times 5. 4 minus 15 is negative 11. As you work through these, guys, there's plenty of places for you to mess up and make a mistake. So what you want to do is you want to check it, and in worst case scenario, guys, worst case scenario, check it with your calculator doing it as a matrix. Because if you check it using it as your calculator, you'll know you'll get negative 2, negative 3. But guys, you can't solve the problem using a calculator if you don't write this. I got to see that. I got to know that you can do this by hand. Okay? And so that's why I gave you that page Tuesday and asked you to simply set the stuff up. You didn't necessarily have to solve it. Guys, you didn't necessarily have to solve it. You just had to set your 3 matrices up. So when you set your denominator matrix, my coefficient matrix, which is a better term, I think, 3, 7, 1, negative 2. Set up your x, I'm using sub n for numerator, your x numerator matrix by replacing 5, 6 in the x column. Okay. Set your y numerator matrix up. Again, I'm using y sub n to represent y numerator. And take 5, 6 and put it in the y column. Then what goes in the x column is whatever the coefficients are, or the y column, whatever the coefficients are. Those numbers come from right here, because this is the coefficient matrix. And these are the coefficient for x's. These are my coefficient for x's. So I put them in my coefficient for x's. These are my coefficients for y. So I put them in y's. That's x. Or excuse me, that's the answer. Five, 6. This probably would be better if I had used green right there. And it wouldn't get mixed up with the colors that we have. So 5, 6 went there. Okay. Needs my x coefficients. My x coefficients are 3, 1. Then, guys, then it's just a matter of solving determinants. And that will be a question on the test, is to take and find the determinant of a 2 by 2 matrix. So to find the determinant of a 2 by 2 matrix, remember, guys, is just cross multiply. And I said this from the very beginning, and it took us, some of y'all, about a week to finally figure out all that is AD minus BC. That's what you do to find the determinant of a 2 by 2 matrix. To find a determinant of a 2 by 2 matrix, I will use that symbolism right there. It will say DETA, or looks like absolute value. But where we're at, it's not absolute value. Okay, so now I have to write my final answer. I write my final answer is x sub n over d. And that gives me my value for x. Y sub n over d. And that gives me my value for y. Now, how many matrices did I have to make? three determinants. I had to find three determinants. I defined three determinants because there were two variables I was solving for. I was solving for x and I was solving for y. Over here in this problem, how many variables am I solving for? Three. So how many matrices am I going to have to make? Four. Okay? And guys, you use 100% the same exact logic. So the first thing I do, I get my denominator, or my coefficient matrix. So I just take my coefficients. 2, 3, 2, 1, negative 7, 3, 1, 5, and 4. Now, listen to me. On the test, this question shows up. But on the test, this x term is missing. If this x term is missing right there, what was my coefficient? 0. If this z term is missing right here, there would be a 0 there. If this y term would appear, it would be 2, 0, 2 in the matrix. It would be 0, negative 7, 3. It would be 1, 5, 0. That's the way those questions are going to be asked on your test. So as you practice your test, your review tonight, make sure you make note of that. So now, hold on a second. Now it's just a matter of making my numerator matrix out. My y numerator matrix. My z numerator matrix. Yes, question.
Will the 0, like the variable be, like when it's missing, will that only be in the 3 by 3 or will it be in the 2 by 2?
Could be in any of them. Anytime there's one missing. Like here, if it was negative 2y equals 6, then your coefficient matrix would be 3, 7, 0, negative 2. Cross multiply, negative 6 minus 7, that would give you negative 13. Negative 6 minus. All right, so here we go. Define your x column. Take 3, negative 26, and 9, and put in the x value. Define your y matrix. Take 3, negative 26, and 9, and put in for the y's. Z, 3, negative 26, 9, put in for z. Now, these are my x values. These are my y values. These are my z coefficients. So when I replaced the answers, when I replace that x column because I'm looking for x, I go get my other two columns from here. So this would be 3, negative 7, 5, and this would be 2, 3, 4. This would be 2, 1, 1. This would be 2, 3, 4. Then in the Z one, 2, 1, 1, 3, negative 7, 5. Now, if I was worried about finding the answer, what would I have to do to these four matrices? Find the determinant for them. So I would have to find the determinant for these four problems. Now, after I give you the no calculator part, the quickest way to find the determinant of a 3 by 3 matrix is to plug it in your calculator and hit DE2. But now the first time, that's the first time on the test, before you get to use your calculator, you're going to have to find 2, 1, 1, 3, negative 7, 5, 2, 3, 4. You rewrite the first two columns, and then you go through that process that we've talked about. And that process is multiply those numbers. The way we've been doing it is you then multiply these numbers find all those products and subtract. Where that comes in is when we did this yesterday. Remember, we said away, or excuse me, whatever day that was, Tuesday. a way or a usefulness of 3x3 matrices is to find the area of a triangle. Okay? Again, in my 7th period class, somebody said the answer to this area was 0. Is that possible? No, you got a mistake. Somebody in another period class said the answer was a negative. No, that can't be true either. Remember, when it was a negative, you multiplied by negative 1/2. And when it's a positive, you multiply by positive 1/2. You got a question here? So, in the one that so I had what? I had 3, 7, 0, -2. So that would be -6 minus 0. You see what he's saying? Yeah. I made a mistake on that. Good catch. -6. I said -7 right there, thinking that was a 1, which is what it was in the problem. Good catch. All right, anybody?